Hello everybody, welcome to lecture 1 of Engineering 102 for winter quarter 2016. In the previous class what we saw was a motivation for why we study dynamics and the syllabus. We also covered what the syllabus is going to comprise and just gave you an overview of what we can expect to see in the class, the kinds of problems we might attempt to solve, and just why dynamics is studied basically. In this lecture, which is why I call it lecture 1, we're going to start looking at some of the technical stuff that underlies the principles of dynamics. So we're going to start with a review on vectors, right? Vectors. So vectors are any quantity that has magnitude and direction, and often you've seen them represented by something like this, right? You see a line segment, right? And then you put an arrowhead on it. So let me highlight what I'm trying to talk about here so that we know what this is. So this is the arrowhead, which is in yellow, and this thing in pink over here is the tail of the vector, right? So tail and arrowhead. Arrowhead. Yeah, I just avoided putting an arrowhead to the term arrowhead over here, so yeah, just not to confuse you guys. So this is the vector, and we'll give it a name. We like to name things, so we'll just call it the vector A for now. So let's remind ourselves that vector is a quantity. So QTY over here means quantity with magnitude and direction, right? Let's say a quantity. So vector is a quantity with magnitude and direction, and we can see that this vector A has a certain length, which is its magnitude, in a certain direction. So that basically covers what the definition of a vector is with that image. Similarly, we could say have another vector B. We'll draw it in green just to distinguish it as a totally different vector. This is the vector B, which also has an arrowhead over there and a tail to its left. Then we could draw another vector C with an arrowhead saying that it's acting from the top right of that section of the page to the bottom left. So these are just some examples of what vectors can look like, and this is what they'll probably look like in the class as well, in exams, homeworks, and blah, 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 stuff like that. All right. From here, let's see. Like I said, we like to name our vectors. Simple ones like A and B, etc. One important thing to note with vectors is that the vector usually has a tilde under it. Vector is denoted with a tilde, right? So you have the letter A for that vector, but we put a tilde underneath, right? So I'm going to highlight what the tilde is so that you know what I'm talking about. That is the tilde, right? So we put a tilde underneath it. Other conventions for naming vectors can be you write the letter A for some vector A and you put something on top like that, or you could also just do something like this, or you could do something like that. If you use a convention, you should let me know, maybe in the exam or something like that, that this is the convention for what you're calling a vector. All right, so there's that. Unit vectors, on the other hand, have a different notation, and we'll come to that in a little bit. Okay. On the previous page, the vectors A, B, and C were vectors in the plane, are vectors in the plane of the paper, right? So we drew it in the plane of the paper. So that just means that they had only two possible directions they could move in, which was the two perpendicular directions of this sheet of paper. It could not come out of the screen or out of the page that you're looking at, right?